Welcome to this Maths Heroes video. My name's Christine. I actually wanted to do a little bit on multiplication and division today because it is usually more about fear than it is about being flexible. So today it's all about being flexible. And it comes back to a question I had from a year 10 girl quite a number of years ago. We were doing indices where you do 3 cubed multiplied by 3 squared. So 1, 2, 3, 4, 5. So this was my 3 cubed, this was my 3 squared. And she said, Miss, I can't do 27 times 9. She knew that that was going to be 27 multiplied by 9. And, you know, this is a question that you may give someone in upper primary school. So that's where I thought I'd start today. And I said to her, I know you can do that because I drew a 10 frame and I put 27 in each box. I've learned if students struggling to separate it out. Sometimes I used to do the 27 like this. I would write it as the 20 and the 7 to try and split it up, but that still wasn't enough differentiation for them to be able to see the numbers. But here you can see that I've got 270. So I've got 100 across the top in orange, 100 across the bottom in orange as well. So it's 270. So what we did was we said, okay, we want 9 groups, means I've got to get rid of 1 group. So here I am on my number line at 270 and I've got to take away 27. So my first hop, I might take away 20 to get to 250, and then I can take away 7 to get to 243. If your students think about taking away 30, so 27 is actually, so taking away 27 is actually taking away 30, but then I have to add 3. So that's taking away 30 and then adding 3. So if they're happy doing that, feel free to do that. You can take away the 7 first and then take away the 20. There is no one right way. That's about being flexible. So she actually started to do, she actually said, well, I know that I've got 27, and she was trying to multiply it by 3. So now in hindsight, my thinking is more flexible. I would have been able to write 27 is 30 take away 3 times. And that becomes 90 take away 9. And that is equal to 81. So 27 times 3 is 81. Could I have drawn a picture for that? You betcha I can. So I always draw a box. So I'm multiplying by 3 and I want to do 27. So I've got, actually I'll do that in orange. So I've got 20 plus 7 and I will end up with 3 lots of 20 is 60 and 3 lots of 7 is 21. That's the formal algorithm method. If I was drawing it this way, the way I've just shown you there, I would say, well, I've got 3. Would be nice. I know how to do 30. That would be 90. And some people take it away on the box. It doesn't matter how you write it, but there's 30 take away 3. So this must be taking away 9. And again, I get my 81. So it doesn't matter which way you go. And to me, this is the F in flexible. So efficient, accurate, repeatable is ear. And if we want to make it fear, then it's flexible, efficient, accurate, and repeatable. So we don't want fear, we want flexible. Another one that I come across, you know, there's all these tricks to learn your 9 times tables and your 9 facts. And realistically, it doesn't work past 10. So students often struggle. So I want to show you a couple of different ways, you know, if you don't want to do facts, that they can do it flexibly. So if I'm thinking about the relationship between 9 and 81, I can see that 81 is actually 90 take away 9. That's really nice to know, because when I'm dividing it by 9, that would be, how many 9s are there in 90? 10. How many 9s are there in 9? 1. Let's draw the picture of that. Okay. So the first thing, I'm dividing by 9, but the first thing I said was, I know that 10 9s are 90. That's that first one there. But I only need 81, so I've got to take away 9. Well, the only way I can get that is if this is take away 1. So I've got to take away one group of 9. So here you can see the 9 as 10 take away 1, and the 81 is the 90 minus 9 inside. That gives students a thinking way to solve a problem. Maybe your students know that 9 is equal to 3 by 3. So here is my picture. I'll just scooch down a little bit. Right, so here is my picture. So to divide by 9, if multiplying by 9 is multiplying by 3 and multiplying by 3 again, thirding must be the way to undo dividing by 9. So let's put 81 in here. So my first question is 81 divided by 3. Ugh. Don't know that one off the top of my head, but what I do know about 3 is that 60 is 20 times 3, and I've got 21 more. So now when I'm dividing 81 by 3, I'm going to divide those both by 3. So I could say 81 over 3. That's a 3. But that's 20 plus 7. So now I know that this is 27. And then it's the same deal, you know, how do I third 27? Well, 27 is 30 take away 3. I'm going to third that, and that will give me 10 minus 1. So I know that this is 9. If they don't know 9 3s are 27, you need to give them another way other than just asking them to memorise it. So there are other ways. So that's seeing 9 as 3 3s. So here you can see 9 multiplied by 9 equals 81. How else could I have done that? Oh, there's lots of ways. Let's try. Over here, let's draw the picture for this one, right? So here I've got 3 lots of 20 is 60. How much more have I got left? Well, I've got 81 to share between 3, so I've got 21 left over. And I know 3 7s are 21. If I didn't know that, I might just even go back to 12 and then, you know, move across and got there as well. But I know 7 3s are 21, 3 7s, and there is my 27 again. That equals 81. If I was doing short division, you know, the good old algorithm, here is 81. I've got to divide by 3. That 2 is the 20 that's in both of those pictures there, those two examples. So that's the 60. There's 20 left over, which becomes 21 ones, and then I've got 7 3s are 21, and I've got to divide by 3 again to be able to do that. That's the problem with numbers less than 10. I've still got 27 divided by 3. I still have to either know it or have some sort of strategy. So that's when, you know, seeing it as a different way will get me the answer, knowing that 9 3s are 27. Beautiful. The picture for this one here, let's draw that one in black. The picture for this one here, well, I'm dividing by 3. And I've got 27. Well, I know that 10 3s are 30, and I'm going to take away 3 off that, and that is take away 9, which would give me my 21. No, let me take that back. Let me take that back because I've got 3s and 9s. It's actually 10 take away. I only want 27, so I only need to take away 3, which is one group of 3. So 3 tens are 30, 3 groups of -1, give me $1, give me $1, give me $1, you've given me $3, that's 27. So here is my 9, 9 threes are 27. So they're the pictures that go with the fractions, that go with the short division, that allow our students to be flexible. Alrighty, here let's do some division. So if I've got 108 divided by 6, you could do the short division algorithm and you would get 18. Before the short division algorithm, you could even teach your students, well, how do I get to 6? Well, it's 2 3s, 3 2s. So I could take 108 and halve it. What's a half of 100? 50. What's a half of 8 is 4. And then I've still got to divide 54 by 3. So how do I do 54 divided by 3? Well, if I'm going to share 54 between 3, what if I thought about it as 60 take away 6 and shared it between 3? That would be much friendlier. So that's 20 minus 2, which is again 18. Here is the picture that goes with that. All right, I'll do it a different way as well. So here is the picture that goes with that one, or a picture that goes with that one. I've got 108, I halve it to get 54, right? And I could think of 54 even as 30 plus 24 if I knew, so 54, I can think of it as 60 take away 6, I can think of it as, I've divided by 3, so I'm thinking of it as 30 plus 24. Either way, it doesn't matter because when I'm dividing by 3, I will get 10 plus 8 or 20 minus 2. Either way, I will get 18. That's one way to do it. Here's another way. Let's show some flexibility. So instead of doing 2 and then 3, let's do 3 and then 2. So the first thing is, oh, yuck, 108 divided by 3. Ugh. That one doesn't seem to be that friendly, but let's make it friendly. Well, close to that is 90, and I reckon I can third 90. How much have I got left over? Well, 90 to 108 is 18. I'm going to share that between 3. So now I've got a third of 90 is 30, and how many 3s are there in 18? There are 6. So now I've got 36, and I now have to halve 36. Any way that you know how to halve 36, maybe you think of 36 as 20 plus 16, and we're going to halve them all. Well, there's my 10 plus 8. You might see it as 40 take away 4, so you might have to halve those, and you'll get 20 take away 2. Either way, you'll still get to 18. So the picture for that one looks like this. So I've got to third first and then halve. So 108, when I share it between 3, I get 36. And when I share it between 2, I get 18. Here is the picture as an area model. If I was doing 6, I might say, hey, I know that 10 6s are 60. What have I got left over? Maybe I don't know. I don't know how to do the other one. But if 10 6s are 60, 5 6s must be 30. Oh, that got me a lot closer because now I'm at 90. So now I've only got another 18 to go. And I know that 3 6s are 18. So there, 10 plus 5 plus 3 is 18. So 18 multiplied by 6 is 108. So that's another way that you can do it. So I hope that you see that we can teach our students to be flexible, to give them something to think about, whether it's a box like the purple ones or the green ones or the other ones that I showed. Everyone can be a maths hero. And I look forward to seeing you next time, and I hope I made you think. And thanks for watching. Bye for now.